Okay, so our second problem is g of x equals x minus 5 quantity squared. And if you need to, you can rewrite at the top of the page that we're always looking for a times quantity x minus h squared plus k. That is always our foundational equation when we're using our shifting technique. Okay, so when I look at number 2, I can identify the number in front of the parenthesis or in front of x as being 1, and that tells me that my a is going to be 1. That also tells me that my graph will open up. I'm not going to flip this over an x-axis at all. I'm just going to open it up. Now there is a number inside of parenthesis this time, which tells us that we have an h value. The number inside our parenthesis says minus 5, and you're going to notice that in the formula already has a minus sign. So this is the only tricky part about using this formula, is that formula says minus h, and our equation says minus 5. So the minus in our equation of x minus 5, that minus is just part of the formula, and our h value is 5. Essentially, you take the opposite of what you're seeing, because that minus is part of the formula. Since our h is 5, we're going to be moving right 5. We should identify our k value before we go to our graph. On this particular problem, there's no number added outside the parenthesis, so our k value is 0, and there's no movement up or down. Now that we have all the critical pieces of information, we come over to our graph. I already printed on there the equation for y equals x squared. So we just take this graph, we move it the vertex right 5. Okay, the vertex is at the origin, and if I move it right 5, it's going to sit on the x-axis right at 5. So our vertex is the ordered pair 5, 0. It also happens to be our x-intercept, just because it's on the x-axis. Okay, so from that vertex, I'm going to go right 1 and up 1. Remember, I'm going up 1 because if I square 1, I get 1. Put symmetry in there, so I have my point to the left. If I go back to my vertex, I'm going to go right 2, I square 2, so I go up 4. And put in a 5th point by creating symmetry, going left 2 and up 4. That should be enough points to draw a good parabola. If not, then you can go back to your vertex. You can go right 3 and up 9, or left 3 and up 9. Now on this particular graph, it doesn't look like there is a y-intercept, but there would eventually be a y-intercept. It's just that we didn't graph it. Number 3 is a combination of problems 1 and 2. So you might be identifying some of those pieces real quickly. If I put in a silent 1 in front of that parenthesis, I can identify that my a value is 1, so I know I am opening up. I can identify that the h value is 5. The equation says x minus 5, but I remember that that minus is part of the formula, so my h is just 5, which means that we're going to move right 5. We're moving right since it's a positive 5. And we can identify that the k value is negative 4, so I will be going down 4. I'm going to start with my parabola that's already printed on the graph, and I'm going to take that vertex that's at the origin 0, 0. I'm going to first use the h and the k value. I'm going to move right 5, and I'm going to move down 4. That means that my point of my vertex is going to be at the ordered pair 5, negative 4. So you may have noticed a pattern that when you identify what your h value is and what your k value is, you're actually identifying the ordered pair of your vertex. Once we have that as our vertex, we can use the fact that we can go right 1 and up 1, and left 1 and up 1. Then I go back to my vertex, I go right 2 and up 4. Then I go left 2 and up 4. Those 2 points are right on the x-axis, so those are going to be my x-intercepts, and those x-intercepts have a value of 7 and a value of 3. If you want additional points, then you go back to your vertex, you go right 3 and up 9. Then you draw your parabola. Moving on to number 4, we have g of x equals negative x squared. That's all it is negative x squared. Nothing added to it, nothing subtracted to it. So the number in front of x squared happens to be a silent negative 1 this time. So a is negative 1, which means that our parabola is going to open down. Whenever a is negative, your parabola opens down. Since there is no parenthesis and there is no number added to x squared, our h is 0, which means we have no movement left or right. And also, there is no k value, so we have no movement up or down. The only movement we have is that our parabola should be opening down. That means that our existing vertex is going to stay right at 0, 0. That is going to be our vertex at 0, 0. When we want to create our other points, when we go right 1, we're going to go down 1 this time. That way our parabola opens down. And if I go left 1, I will go down 1. Going back to the vertex, if I go right 2, I will go down 4. If I choose to go to the right 3, I would go down 9. I connect my points, and I have my parabola opening down. When you have your points connected, you'll notice that if you were to fold your paper in half, right over the x-axis, that the original x squared and now our graph for negative x squared, they would line up right on top of each other.